Okay, I'm ready. Every time you say I could start my presentation.
You can't start now. Just share your presentation. You can't start.
Okay, thank you.
السلام عليكم دكتور علي حبيبي تسمعني دكتور علي؟
السلام. اي نعم اسمعك دكتور سمعك. اي نعم.
حياك الله يسلمك دكتور. دكتور لك المنصة حضرتك انت تدير الجلسة ان شاء الله.
ان شاء الله ان شاء الله.
الله يحفظك الله يسلمك. زين.
السلام عليكم دكتور سارة.
Hello.
Hello. Yeah, I am Dr. Ali Al-Idani. I am a lecturer in the Computer Engineering Department.
Glad to meet you here. Thank you.
Thank you. So, first of all, just I will explain to our student about this presentation. Okay.
Okay. Thank you.
السلام عليكم طلاب. اليوم عندنا محاضرة حول الامبيدد سيستم. طبعا المحاضرة حتلقيها الدكتورة سارة أرشدي، هي يعني استاذ مساعد في جامعة فردوس. فطبعا حتكون حول الامبيدد سيستم، اكثريتكم تعرفون عن الامبيدد سيستم، فان شاء الله تكون تستفادون من هذه المحاضرة. Dear student, today we have a lecture about embedded system. Most of you know what is embedded system. So I hope to take advantage of this opportunity. Today we have Dr. Sara Ershadi. She's the associate prof in Fordosi University. Welcome, doctor. You can start now.
Okay, thank you very much. I'm very glad to be here, and I hope all of us can learn something new today. My today's talk is about the embedded system and its applications. I am Sara Ershadi Nasab. Now I am assistant professor in computer group here in Ferdowsi University of Mashhad, Iran. I got my PhD from Sharif University of Technology in Tehran. I put my email address here during my talk, and after that, if you want to contact me, you can you can send email by this email address to me. I will be very glad to share with you this PowerPoint and other PDF and all thing you want. And I hope such a thing could bring for us new opportunity for further collaborations. The content of our today's talk is about embedded system overview at the first part, and after that I will talk about the Arduino and its applications and somehow coding dilemma in Arduino environment. And this is a brief introduction about the Arduino and its application. And I hope you enjoy this talk. In fact, embedded system has lots of application in our today life. There are lots of stuff and application between us that inside all of them there are chipset and there are board that are designed by embedded system methods and hardware solution. And we want to find more about the internal of these devices. all of the embedded system contained a main board or a chipset. For example, here you see a blue board, several ICs and capacitors, resistors installed on it, and this board usually performed a specific task. Inside this board, there are some black area that are ICs. These ICs are from 3 different categories. This might be microcontrollers or microprocessors or DSP ICs. DSP means digital signal processors. There are some differences between these 3 types. Today, I want to discuss more about the microcontroller, and as an example of embedded system, I will emphasize on the Arduino board as an embedded system and 80 mega pseudo as a microcontroller installed on it. Every microcontroller, as you can see in this picture, is a black IC installed on a board. By programming skills, we can communicate with this IC and program it for our special task and enforce it to do our desired operations. But microcontroller and chipset has a very different application and different operation with PC generally. I will discuss about it in later slides. Development platform is a environment that the software engineer perform coding operation and could interact with the board and chipset by using his or her PC. Development component platform contains host machines, development environment, compiler toolchains, development kits, and version control. Version control that is very useful when our project turns very big and there are lots of code in it, and we want to manage all of them and change a small piece of code between lots of code. And in this situation, we should use version control software such as Git, GitHub, and so on. Every embedded system has development component, and we should interact with them using software packages. Using our self PC and installed software on it, I start coding in an environment specified for coding, and after that I should compile my code to get it ready to be transferred to the embedded chip and to program it. This process of converting these codes that are written in a text or notepad to the binary code that is executable for machines, we need a compiler. Our compiler in this design are GCC if we are using Linux, and GNU Make. Since the most popular coding language in this category is C, that is very near to machine language, we need GCC compiler. We should know something about the memory type, about the segment, and about the management operation between the memory and bus and internal structure of microcontroller and chips. All of them are will be available by coding and by C languages. Okay, therefore, embedded system overview contains environment, hardware part, software skill, and our coding section, mainly by C programming. And after that, after our code gets so much bigger and bigger, we need software for controlling our change in the code that is possible but by GitHub and GitLab. These are tools for version control of our package. Because we are writing a package that control the board. This board is designed for a specific application. For example, for weather prediction or something else. But this board only could do that application that we code and program it for doing such operations. Compilation will be performed with GCC and GNU Makes, and our code will be built, and binary machine code will be available. And now we should transfer them to the embedded system board. And we should know about memory system and memory section and software to hardware memory interfaces, and should be able to write code that could be run on different program segments. In this slide, you can see, for example, Code Composer Studio V6. That is an environment for you to write your code, or Kinetics Design Studio. These two are two ID environment for you to make it possible to write easy code. And after that, this red board or this black board are our AIM chipset that are that is desired for us to send and program to it. If you want this lecture be very useful for you, you should be an electrical engineering or a computer engineer, and you should know something about the current, voltage, power. Also, you should know the meaning of resistors, capacitors, and you should know about the assembly language. I said that we write our code with C programming language, but it is very important that you know the assembly language and be aware of the main assembly language of the main microcontroller over the chipset, over the embedded system board. Okay, and we talk about all of them during this talk. Here we want to define the different components of an embedded system and try to introduce Git version control, GNU's compiler, and try to write the portable software that could be run in architecture of a embedded system. Our code will be in C programming language, or because I said that in the second part of my conversation, I will emphasize on the Arduino board. Our code could be in Arduino language. Okay, if you want to define an embedded system generally, an embedded system is a computerized system that is built for doing a specific application. Any embedded system has some limitation about its processing strength, its memory, available memory on the board, and its strength in communicating with peripheral devices. Because embedded system is not a PC or a computer. It has only a board, and on this board there are lots of limitations about the processing, about the memory, and about the how to communicate with other devices. Therefore, embedded system is not a PC or is not a server, and it's only a chipset, a board, inside very devices around us. Computers are a general purpose machine that could run a lots of different programs on it, and it is not optimized for a specific task. But dishwashing machine, for example, is designed for a specific task and programmed for only this task, and it couldn't perform other tasks. This is the main difference between the embedded system and a general PC or server. If you want to emphasize on the inside of the embedded system development platform, you can see here any embedded system contains a wafer substrate, usually green, or here I show some red version of them in previous slide. It is a PCB. PCB is a printed circuit board. Every PCB contains the processor elements, the power section, and the section for external hardware that we discuss about all of them in the upcoming slide. Also, in every chipset, there is a programmer or debugging section that is dedicated to a specific IC that we will show it to you. This IC is dedicated to debugging or programming operation. Inside, we emphasize on the inside of a microcontroller. Okay, and every microcontroller should communicate with the host machine. The host machine is our PC, for example, where we write our code. Using USB cables, we could communicate and connect our embedded system to the PC. Software engineer do this part. They interact with PC and write their code, and after that, hardware engineer tries to connect this embedded system board to the PC using these peripheral cables. This is an example of embedded system. The printed circuit board here is in red color. There is two ICs over this board. This IC is the main processor of this board. This is, I think this is an ARM processor. And here is the second IC installed on this board. Its dedicated task is for debugging operation and for performing communication through USB to the host machine and sending the machine binary codes to the main IC over this board. Okay, this is the main IC and this is the secondary IC. All of them are microcontroller installed on a red printed circuit board. Here, there are lots of input-output connection pins. With input-output connection pins, you can connect wires to these pins and get inputs or output to this board, send data and get data to this board. There are lots of resistor and capacitor inside this board. Generally, this board is designed with schematic software and here is a microcontroller with very tiny pins that is not suitable for us to interact with them. But when this IC is installed on this board, using this input-output pin, it is very more easier for us to have a communication, easy communication and easy use for this board. Okay, here I want to talk more about the inside of any ICs, inside of this microcontroller. Every microcontroller contains a central processing unit or CPU. A CPU performs all the computation tasks and works that we expect from IC to do. CPU is responsible for doing all operations that we expect. This is a central processing unit. CPU contained registers. Registers are the very tiny element of memory. Registers are memories, but very tiny. There are two different forms of register, a special purpose register and general purpose register inside the CPU, inside the microcontroller. And inside every CPU, there is arithmetic logic unit, ALU, that performs all the logic operation, logic commands, for example, AND, OR, XOR, NOR, NOT, logic operation that we expect the CPU perform then. Inside every CPU, there is interrupt controller module and a very module for debug operations. In this picture, you can see different part of CPU, different part of microcontroller. Memory section contains RAM, flash, ports, input output, and GPIO. GPIO are general purpose input output port. Peripheral devices could connect here, and bus controller responsible for sending and receiving data between memory and between the microcontroller. CPU here contains registers, ALU, interrupt controller, and debugger section. Power management circuits are installed here on the board, and there is also another section for clocks operation and for synchronized operation inside the board. Okay, here you can see an example of Cortex M4 microcontroller. That is a high-speed microcontroller, MSP432. And you can see different part of this microcontroller. All of this picture is a tiny black box inside the red board, red PCB. This is a IC and contains different parts. The name of this IC is Cortex M4, a high-speed microcontroller. Contains the ADC. ADC means analog to digital conversion. The part that convert the analog data to digital data to be usable for doing digital operation. Here is the power supply system, PCM, power control management, bus control logic, DMA, direct memory access, channels, MPU, and other different sections. Okay? In this picture, you can see the bigger module that contains the previous picture. All of here are CPU, processor support are here, direct memory access, buses are here and here, memory section is here, flash, SRAM, ROM, processor support are here, RSTCTCL, AES, coding, security, encryption, description, CRC. These are AES and CRC are two types of coding operation because of the security. Communication via USCI, UART, SPI, Serial Peripheral Interface, PC, and clock and timing here. There is a 16-bit timer here and two 32-bit timer here. And also input-output port, memory, clock, and timing, all of them inside the Cortex M4 microcontroller. Okay, both these two pictures over there. We interact with this IC and also with this board and with this PCB as an embedded system with software block diagram, with writing C file as modules. We write our code modulars. Yeah, it means that we have a very special structure in our coding and in our procedures. GPIO hardware is the button in our procedure, and after that, serial peripheral interface are communicating with GPIO interfaces. And other modular code and libraries over them interact with the GPIO hardware. Software in layers are shown in this picture. Software layers may be application layer or middleware layer after a small lower than the application is the middleware layer. And after that, the operating system. After that, the driver, and in the bottom of them, it is the hardware layer. If we want to communicate with the hardware layer, it is possible by using different drivers, different bootloader, and after that, operating system uses drivers. And here, approximately, we could interact with the hardware. And after that, the middleware layer is very helpful for the application layer. And in application layer, such as Android app, we have interact with the hardware without any notation about that we have interaction with the hardware. We play our app on the Android mobile cell phone, and we haven't any sense about how we interact with the hardware, because this is possible by lots of middleware layer, operating system layer, and after that the driver, and we haven't any direct connection to the hardware. It is possible by using lots of different libraries. OS very important. For example, my OS here is Windows. I am using a PC, and by using a operating system Windows 10, I have it is possible for me to use my PC and to present my work to you. Or for example, for your cell phone, your OS might be Android, or you might have Apple and another OS. There is also hardware abstraction layer, HAL. Hardware code are also modular, and some of them have near interaction with the hardware input-output, but some of them are more near to the software layers. And there is also this hierarchy in hardware abstraction layer as the software abstraction layers too. Okay, here you see the overall picture of this software component of this IC, and for example, you can see GPIO module here that connect to 3 red, green, blue LED here. UART, universal asynchron receiver and transmitter port, to off-board connection to other boards. And I said you that the version control is very important, because all of the module that is shown here are library, and for example, UART library, after being legacy, will be removed from here. A newer version of it will be updated. Newer version of any any embedded system will help us to have hardware without any bug, without any interruption, without any problem. Because in newer version library, all bug and all problem are resolved. And here, version control is very important, because we should be aware of what was the past version of this library and what is the newer version, what is the difference between them, and what is the changes, why this is changed, and we should know, and how perform this change. It might be we have several hundred engineers in our team, and we should be aware of which of them who change the code. And this is very important for our big project. Okay, this is an example of programmer or debugger. I will show you a very simpler version of them, but this is a programmer debugger. By using it, you can connect this cable to the PC and also to the embedded board and program it. And after that, the embedded system is ready to use. Another software engineer tools are simulator, emulator. Simulator and emulator are software that make it possible for us to have a vision about our design before we will send our design to the manufacturer. Because of the cost, we at first simulate everything, and after that, after we are 100% sure about the all functionality are working through, and there isn't any problem in our design, in our software. After that, we send our project to the manufacturer to production. And therefore, we should at first simulate and emulate all things to be aware of the bug inside our code and our hardware. Compiler, as I said before, tries to convert our code that are in Notepad++ or the C file or assembly file, ordinary text file, convert them to binary machine code that could be that should be translated to machine code that could be enabled by the embedded system. And after that, we will use the software as installer and debugger for debugging operations. I said that we should and we want to write some codes. Our code should be maintainable, testable, portable, robust, efficient, and consistent. For a specific application to be very, very useful for us. Portability is very important for the code that we are write, because here I am using Windows 10. You might use another version of Windows or another version of OS. Our code should be portable. That could be run also in Linux, in Windows, in different Android version. This is portable codes. As you can see here in this picture, embedded software might use several languages such as C, C++, Java, and other. And the language C here in yellow color is the most popular language in embedded software programming. In embedded C features is also very similar to C, and it is in fact the part of C language that are very near to hardware parts. It is embedded C, therefore embedded C is C, but the parts of C that are near to hardware operation. Embedded C has optimum features that is very useful for hardware interaction. It has very different functions for efficient memory management that are very useful for timing operations, for code size constraint, and optimized execution. Okay, here I finished my first part of my talk that was about the original and general embedded system. I will be very glad if you have a question. You could chat with me if it is possible for you and ask your question about the first part of this talk.
اوكي. طلاب اذا كل واحد عنده سؤال على الجزء الاول من السيمينار. Student, if you have any question about the first part of the seminar, about the ARM embedded system. Okay. Actually, we have used in our lab about the Arduino. So mostly have interested in Arduino parts. Okay. You can keep going, Victor. Thank you.
Okay. Thank you. I am very glad that you are using Arduino too, and I hope that all of us could learn something new about the Arduino and its application here. And also, my email address is sara.ershadinasab@gmail.com. If you have any question, I will be very glad. After this talk, you could send your question to me.
Yes, sure. Thank you very much.
Okay. The second part of this talk is about the Arduino. Arduino is the name of the company in Italy that designed schematic and some sort of embedded system and tries to produce and manufacture, and after that sell this board during the world. Okay, this is an example of Arduino Uno board. You can see here, this is made in Italy, example of Arduino Uno. And during this talk, I will talk about the different part of this code, and by using a simple program inside the Arduino, we will try to learn more about the Arduino Uno and different specification of it. With using Arduino, here you can see this is a motor, and you can see turn the motor by using the very simple circuit and connecting them to the Arduino. You can use the Arduino as an oscilloscope. And here you can see a waveform plotted in the plotter of the Arduino. Inside of the Arduino board, there is a microcontroller. It is a microcontroller. This is pins, and it is 80 mega 32 microcontroller by Atmel. This is the original website of Arduino, www.arduino.cc, and you can different Arduino modules here. Arduino Tian, here Arduino Tian, very small 32-bit microcontroller. Arduino Ethernet. Ethernet could connect to the internet and do such operation wirelessly via the internet. There are two different Arduino modules. One that is made in Italy, and the other is case study. Arduino is an open source platform. The hardware and installation, the different microcontroller and IC between them is open source, and different companies try to manufacture this board and try to sell them. The difference between them is in cost of them. Arduino, cost is not very much, but different prices between different companies, but all the functionality of the same. Here you can see that when we want to use Arduino, there is a helpful shield that help us to connect the Arduino board to this shield for easy connection to other devices. For example, Adafruit is a company that design and sell, for example, motor stepper servo shield for Arduino, or NFC RFID controller shield for Arduino. Here is another company such as SparkFun. SparkFun produces several different boards, all of them in red. For example, for weather, or for cell phone connection, or MP3 connection, Wi-Fi shield. When we want to use Arduino for a Wi-Fi connection, we should use this Arduino board differently than when we want to use the Arduino in weather operation or weather project. Because of that, different shields are designed and are available, and if you it is related to our project that we choose which of them. If we have a Wi-Fi project, we use this Wi-Fi shield. If we have a weather project for weather forecasting, we use this shield. Or for connecting MP3 player, it is possible for us to use this shield. Communicating and connecting this Arduino board to the computer is not a very difficult task. It is possible very easily by only one USB cable to this Arduino board, and the other side of the cable to the USB port of the PC. Arduino has it's a specific language for programming. This language has its own structure. Its internal structure should contain two different functions: setup and loop. Setup and loop, both of them, are in all of the code, all of the Arduino codes. Control structure are very similar to C: if else, for, switch case. While if you know C, it is not a very difficult task for you to use Arduino. Variables are very similar to C. Data type are also very similar: void, boolean, character, byte. And also there are very useful functions for input-output connection: digital write, digital read; for analog input-output, analog reference, analog read, analog write. Analog write is very important because it made it possible to use pulse width modulation. And also analog read resolution and analog write resolution. Okay, Arduino Uno, and we will talk about the different part of this embedded system. This is a main IC over this board. This is a microcontroller that we talk about it in previous slides. It's a 32-bit microcontroller. It is a AVR microcontroller. 80MegaThirty28 P microchip produced by Atmel, and it is a type of microcontroller. Okay, here there is it is shown here a resonator. Resonator is responsible for producing needed clock for internal operation of the IC. For internal operation of the IC, it is needed that we have a clock. Clock will be produced by using a resonator and also an oscillator here. It is the secondary IC inside this board. It is also Atmel 8 Mega 8U2. This Atmel microcontroller is responsible for debugging operation and for sending code to the main processor of the board to facilitate the the run of operation and command during the program operations. Okay, here you can see the adapter pin. 9-volt is the DC power supply adapter pin. This is and here you can see the USB connection of the board. If you connect the USB cable to this board and also to the PC USB port, this board has a power supply. By about 5-volt DC power, this board could operate correctly. But if you want, but it is connected to PC. And if you want to remove this connection from the PC and install this board in a different location, for example, in very hard access location, we want to install this board a different location, not very near to the PC and connecting the cable all of the time to the PC. Okay, if this situation appeared, we can use this pin adapter, and by using this pin adapter, we have the needed power of this PC. And it is not necessary to for us to use in all of the time USB connection to the PC. Okay, it is a regulator that converts the DC power, 9-volt DC power, to our desired DC power that is 5-volt DC power or 3.3 DC power that is needed for input-output pins of the board. Okay, this is a reset button. If you want to program the board and if you want to do this board do another task, if you want this board do another task from the first task, you can program this board initially, and if the operation failed, you can press this reset button, and it made the clear all the memory section of the board, and the board will be ready to program again. Okay, here are input-output port of the board. The reset pin, the 3.3-volt pin, 5-volt pin, 2 ground pin, and a specific pin for input voltage. These all of them are power pins at the edge of the board. Here you can see the TX RX pins. TX RX help us to transmit and receive data to this board for serial communication. Here you can see the analog input pin. A0 to A5 are 6 input pin that could get input from data. For example, from different sensors. Okay, you want to use this Arduino board for weather prediction task. You want to establish a weather station, a weather prediction station. Okay, and you want to measure the amounts of humidity of the soil, of the amounts of humidity of the weather. Okay, by using different sensors, you can measure this data. And when you want to send this data to the computer, it is possible by connecting the output of the sensor to this analog input pins, and by this connection, this data will be injected and received to the main microcontroller inside this Arduino board. Okay, at first, you should download the Arduino IDE from the Arduino original website, or www.arduino.cc, and try to install it. After the installation, it is the environment of this program. This is the internal environment of this software. When you want to connect, when you want to be sure about the correct operation and correct functionality of the board, it is very easy task. You should connect the your embedded board, your Arduino board, using the USB cables to the USB port of the computer, and after that, by using Tools menu, set the board to the Arduino GNU Uno. If your Arduino board name is Uno, you might have different Arduino board, for example, Arduino Mega, Arduino Nano, Arduino Yuan. If you have Arduino Uno, you set in Arduino Uno. And there are lots of very interesting examples here. You can use the menu file, and after that example, and in basic section, for example, you can see the analog read serial section. This is example in analog read serial. Analog read serial contains the setup and the void functions, similar to any other Arduino language. All of them contain setup and loop. Setup is the initialization command that is very important for initialization of our board. And the loop function is here that we write our desired code. For example, when we want to read an analog input from the port A0, we use the analog read function and right here A0, because we want to connect the output of sensor to the port A0. We write here A0, analog read from port A0. And this is the integer data. Sensor value is the integer data. And after that, we could perform lots of operation on sensor value. But here, very simple operation. We want to only print this data. Okay, we want to get the data from the sensors and read them from the A0 pin, and after that only print it. For printing, we use serial.printing function and send the sensor value as an input to this function, and wait for 1 millisecond. Here you can see a different application of this Arduino, a very simple application of this. Using a potentiometer, for example, 10 kilo potentiometer or 1 kilo potentiometer, it's a variable resistance. Variable resistance, the maximum of this resistance is 10 kilo and the minimum is 0. By turning this to right or left, we could have a different resistance. And if we connect this potentiometer to the VCC, ground, and A0 here, VCC and ground pins of the Arduino board, we can perform a very interesting project. Here, analog read serial example, and okay, this is the baud rate. Baud rate is the rate of communication, the rate of communicating bits per second. It should have a different number, but here it is enough for us for this communication. Okay, here in a loop, we read the analog read A0 data in a sensor value and try to print it in sensor value. Okay, and this is our hardware. And we could use the tools, and after that the serial monitor section, serial monitor could plot and show us the result of serial printing function. Okay, you see different numbers. Different numbers are available here, every one after each other, and result of this task and result of connecting the potentiometer to the Arduino board. Okay, if we change the amounts of this resistance, the amounts of these numbers varies. But here we want to find out the meaning of this word. They are from 0 to 2023. Analog, but it is possible by using an analog to digital converting value. But the real world voltage value are from 0 to 5. We have voltage from 0 to 5 because the input-output port of the Arduino couldn't be bigger than 5, because the operation of the whole of the board is performed by using the 5-volt voltage, and therefore the input-output port of the Arduino, couldn't be bigger than 5 volts. But here we see that numbers very bigger than 5 volts. It is not a difficult problem. Here you see that there is a map between two numbers. Arduino use a map for showing the numbers with bigger precisions. And if you want to find the real value shown by this voltage value here, you can use this conversion to see their real value. For example, if you see the 512 number in the plotter of the Arduino here, it means that you have 2.5 voltage on this pin. Okay, it is possible by using the serial monitor because you use the serial printing function. And also, it is another special interesting menu, serial plotter. Serial plotter is very helpful menu that if you press it, you see something like it. It is very similar to oscilloscope. The waveform shape will be shown here to you by using the serial plotter. Okay, another example from the file menu examples, you can see the analog in-out serial. Okay, it is a built-in example of the Arduino. You can see the analog in-out serial. For example, here, two different analog pins are defined as A0 and 9. Port 9 is defined as analog output pin. Port A0 is defined as analog input pin. The initial value or sensor value are 0, output value are 0, and the communication is performed in this baud rate. In the loop, we should write our desired code. We get the sensor value by using the analog read function, analog in pin. Analog in pin is, in fact, the A0 pin of the Arduino. And after that, we should use the map function to convert the read value that is between 0 and 5 to 0 and 2023. Output value is in desired range. And after that, we try to get it to analog write function. Output value is here by using the analog write function. And after that, this is desired for better and clear coding. Serial.printer sensor equals to serial.printer sensor value. Sensor value is at first 0 initialized. Sensor print /t output serial.printed output value. And only wait for 2 milliseconds. And after that, iterate on it. It is a loop and iterate on it. Okay, if you want to test this code with the real hardware, we could connect the real potentiometer to the specified port, and also one LED using one resistor to these pins, and by changing the amounts of resistance, the amounts of lightning in this LED will varies from low to very sharp brightness. From low to very light. Here you could connect the pin of this LED to the oscilloscope using this port, and see that the available waveform on the output pin. This is an example of the scar waveform. This is the schematic of the oscilloscope, and you see the pulse width modulation here. Okay, in another project, you can connect the motors by using the breadboard to the Arduino board, and control the speed of motor. Here is a 1 kilo resistant and 100 microfarad capacitor, and connecting both of them to the Arduino. Here via the input and output pins. Okay, that if we could connect these peripheral devices to the Arduino and could use the motor and control the speed of motor, it is possible for us to drive a robot, a very simple robot, something like this. Okay, this is references that are used for our today talk, and I'm ready if there is any question.
Okay. Thank you very much, Doctor.
Thank you very much for your attention to this lecture.
Thank you, Doctor. You have covered the different areas about the hardware and also software, and you have already like solved 2 tasks we have asked our student to do in next lab. We have this lab in morning tomorrow. Yeah, and you have already explained. Thank you very much.
Thank you. It's very kind of you, and I hope it has a very good effect on your students.
Yeah, thank you. Just طلاب إذا أكو واحد عنده سؤال أول ما أطرحها بيتعلق بالأردوينو والبرمجة أو الهاردوير. Dear student, if you have any question about the second part of this seminar which related to the Arduino, okay. Just I have one question. If we compare between AVR and AR and ARM, what is the difference according to the capability?
AVR ICs are introduced in the past decades. These are internally microcontroller and 80 mega 32 is one of the most popular kind of Arduino, a kind of AVR. Arduino is not different things that AVR. Arduino is only the platform that the 80 mega 32 microcontroller is installed on it, and it made it easy for communication to the microcontroller and easy using of it for debugging and for different tasks and operation. But you ask about the ARM microprocessors. ARM are more advanced than AVR microcontrollers. It is very popular that ARM are programmed with C language, and the strength of processing inside ARM is very, very more than AVR microcontroller. The memory inside the ARM, the processor of ARM is much bigger than the AVR. And the strength of ALU is very more advanced, the strength of ALU in the AVR. For example, in today Android cell phone available here, the internal processor are ARM Cortex, different ARM Cortex, because the strength of processing and its ability of processing.
Okay, thank you very much. That means that ARM is more powerful than compared to the AVR according to the capability and the storage and also the programming. But I think the
Yes.
Arduino is more simple for programming and do experiment.
But yes, more powerful from AVR, but AVR with is very easy to
Yes,
communicate
yes,
and to do
yes.
simple projects.
Yeah. And when you said that code is open source, does that mean what we can do that in the C program, or you mean that we can be modify the compiler or debugger of the Arduino?
The Arduino schematic is open source. If you use the ORCAD platforms for any Arduino board, you should use different parts of this IC together. For example, here is another IC, a resonator, an oscillator, different peripheral ICs, different capacitors, connections. The PCB of the Arduino is open source.
Okay, okay. Thank you very much. Thank you. اوكي طلاب اكو واحد عنده سؤال بعد؟ اكو. Okay. Thank you, Doctor. Thank you very much for this opportunity. And I hope we can do more collaboration in the future. Thank you very much.
Thank you very much. It was very interesting for me to have a live communication with you today, and I hope we could see each other in further meetings.
Yeah, thank you. Thank you very much.
Thank you.
اوكي طلاب سنخلص الميتينج تريدون تغادرون. Dear student, currently the seminar is finished, so you can leave the meeting. Thank you very much. Thank you, doctor.
Thank you. Goodbye.
Goodbye.